Hey guys, so now we're going to talk about rotational displacement when you go around a circle multiple times. Let's check it out. So if you make one full revolution, a revolution is a complete circle, a complete cycle, a complete rotation, a complete spin. There's all these words. If you make a full one around a circle, you've gone a total change in angle of 360 degrees. Everyone knows that. A full lap is 360 degrees, or 2 pi radians. Okay. Therefore, delta x, remember the delta x equation is delta x equals r delta theta. That's how you link these two variables. Okay, it becomes 2 pi r. And what I've done here is I replaced delta theta with 2 pi because that's what delta theta is if you make a revolution. And you might recognize this equation that delta x equals 2 pi r. This is the circumference equation. The definition of circumference is the size, the length of the border of a circle. And that's linear distance. If you're driving your car around a circle, your odometer, which tells you how far you've traveled, would give you a quantity equal to 2 pi r. Okay? So that's the linear distance as you go in a rotational motion around a circle. Now that's if you spin once. If you spin once, you get 360. What happens if you spin twice? Then you get 360 times 2. So if you spin any n times, then your delta theta is 360 times n, or 2 pi times n, obviously in radians. So instead of having a delta x of 2 pi r, you get a delta x of 2 pi r times n, where n is the number of rotations. Okay? Two more things you may need to know. If you want to know how many revolutions you go through, and we'll do an example of this just now, all you got to do is divide your number of angles by either 360 degrees or by 2 pi. Okay? For example, if I tell you I spun 720 degrees, and I want to know how many revolutions that is, you divide it by 360 and you get 2. That means I spun twice. Okay? Same thing with if it's in radians, if it's in pi's, you can just divide it by 2 pi. And the last thing is, let's say you go around a circle many times and you end up over here. Okay? If I want to know how far you end up, you don't got to draw this. If I want to know how far I end up, all you got to do is you keep subtracting by 360 until your angle is less than 360. So for example, if you spun 410 degrees and I want to know how far from 0 you end up, 410 is more than 360, so you made multiple revolutions. All I got to do is subtract by 360, and you see that the answer is 50. You keep doing this until your final answer is less than 360, which it is, so we're good to go. If it wasn't, you would subtract by 360 again. Okay. Same thing with radians. If it's in radians, you just keep subtracting by 2 pi until the answer is less than 2 pi. Let's do a quick example here. All right. So starting from 0 degrees, let's draw a little ball, a circle. Starting from here, 0 degrees is always the positive x-axis. You make 2.2 revolutions. So we're using the letter n to represent the number of revolutions, 2.2, around a circular path of radius 20. If you have a circular path of radius 20, that means that your radial distance from the middle, little r, is 20. You could use little r or big R interchangeably. Little r is technically more correct because it's not, big R is reserved for the radius of like a disk. Little r is the distance from the center. Okay, but the words are used kind of interchangeably. All right, so what is your rotational displacement in degrees? Rotational displacement is delta theta, and we want that in degrees. So I'm going to put a little DEG here to indicate that we want to do this in degrees and not in radians. Well, if you spin once, you spin 360 degrees. But if you spin 2.2 times, you just multiply them. Okay, and this is going to give you 792 degrees. 792 degrees is your how much you spun. Cool. That's it for part B. How many degrees from 0 are you? Again, we're just going to subtract 792 until we get to a number that's less than 360. So I want to know how far from 0. Okay, so 792 minus 360, that gives you 432. We're going to have to keep going because we're not below 360, minus 360. And then finally, that's the answer, 72 degrees. Okay, that's the final answer. And for part C, what is your linear displacement? Linear displacement, remember, is delta x. And if I want to know delta x is r delta theta. R is the distance here, 20. And delta theta has to be in radians. Delta theta has to be in radians. So I cannot use 792. Okay, let's just do a little gentle 792. I cannot use that. I'm going to have to use in radians. And in radians, this is going to be 2 pi times 2.2. Right? 2 pi is a full rotation times 2.2 because we rotated 2.2 times. So if you multiply all of this, put in the calculator, pi is 3.1415, but your calculator has a button for that. If you do all this, you get the distance is 276 meters. Okay? That's it for this. Hopefully it made sense. Let me know if you guys have any questions.